So we had finished complex numbers, right? So we'll move on now.
Mhm.
Uh, we'll do binomial theorems. This is not a very difficult or very long chapter. It is fairly straightforward. So it should be mostly be done in one or two classes. Okay.
Yeah.
After binomial theorem, we'll do PNC. Okay. So PNC is permutations and combinations. So right now in your Alan, what is going on? Complex numbers. What is going on in Alan? Hello.
Yeah.
What chapter is going on in your coaching?
So complex numbers only.
Okay. Okay then. We'll start binomial theorem. Just wait for Akhil to join. Uh, okay. Bhavesh is almost done with complex numbers also. Okay. So anyway, these are the chapters that they will be doing after that. So
Mhm.
we will do these, and then we will go back to our parabola, ellipse, hyperbola. Right?
Yeah.
We had done till circles there. Right?
Yeah.
We have to finish that coordinate geometry part also. So we'll go back. So this is the sequence: binomial theorem, PNC, and then this. So okay. So binomial theorem is very simple. It is a rule for explaining how to expand this thing, x plus y to the power n. So this was found by Newton. Newton first proved the binomial theorem, and the expansion, for example, of x plus y to the power 3, right? You already know the formula, right?
Yeah.
X cube plus y cube plus 3xy x plus y, right?
Yeah. Yeah.
So it becomes x cube plus y cube plus 3x square y plus 3xy square. So you write it in this way so that you can see that powers of x are declining and powers of
Yeah.
y are increasing, right?
Yeah.
So similarly, x plus y whole power 4, if you have to do, you can do it by calculation. You can just simply square this,
Mm-hmm.
but we have a formula to write the answer. So we get basically this 4x cube y plus 4 plus 6x square y square plus 4xy cube plus y power 4. Okay.
Yeah.
This will be what it comes out of it. So, and as you go ahead, it becomes more and more difficult to predict what will happen, right?
Mm-hmm. Yeah.
So in general, what is this? This expansion is called binomial theorem. Okay. So let's just look at the pattern here and figure out a way to figure out what these coefficients will be, right? These
Mm-hmm.
coefficients. So there is something called Pascal's triangle. The first thing that we'll look at is Pascal's triangle. Pascal's triangle is constructed like this: 1, 1, 1, 1, 2, 1, 1, 3,
Yeah.
3,
Somewhere.
1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, and so on, right?
Yeah.
You are getting the pattern.
Yeah.
The pattern is you start with 1 and 1, 1, and then after that you start
Adding.
putting each number on the sides, on the both the extremes, it will always be 1,
One. Yeah.
and in the middle the numbers are found by adding the 2 above it.
Yeah.
Yeah.
So 1 plus 2 becomes 3, 2 plus 1 becomes 3, right?
Yeah.
1
Yeah.
plus
Yeah.
3 becomes 4, 3 plus 3 is 6, 3 plus 1 is 4, right?
Yeah.
So
Yeah.
so on, you are getting this triangle. Now what we will notice is that each row each row has one more term than the number of the row. Actually, this denotes the coefficients of x plus y whole square, and this is
Yeah.
x plus y whole cube. Because see, the coefficients of x plus y whole cube were 1, 3, 3, 1, right?
Yeah. Yeah.
And
Yeah.
x square plus y square plus 2xy is 1, 2, 1, right?
Yeah.
Yeah.
Here the expansion was x square plus 2xy plus y square. Here the expansion was x cube plus 3x square y plus 3xy square plus y cube, right?
Yeah. Yeah.
And this is coefficients of x plus y to the power 4, okay? And so on.
Yeah.
So basically, first thing that you should notice is that the number of terms in each expansion is one more than this power, right?
Yeah.
Yeah.
When
Yeah.
you have x plus y whole square, you had 3 terms, and x plus y whole cube, you had
Yes.
4 terms, right?
Mm.
And so on, right?
Yeah.
And then you can find some other patterns also. You can first of all try to understand what is the meaning of these coefficients. So now actually there is a way to find any power coefficients, right?
Yeah.
So you can say the next one will be 21 here and 35 here and 35 here and 21 here and 7 here and then 1 there, right?
Yeah.
But
Yeah.
obviously this process is okay only for small numbers,
Small
otherwise you will
numbers.
not keep making these terms, right?
Hmm.
So you
Yeah.
will not keep building a bigger and bigger triangle, right? It will be difficult.
Yeah.
So it is good for only small numbers. What we will realize is that this triangle actually represents combinatorial coefficients. Combinatorial coefficients, by that meaning NCR, something like that.
Mm-hmm.
Combinatorial coefficients. So we will learn about this NCR soon in the next chapter, permutations and combinations. But what
Mm-hmm.
NCR means for now, you can understand that this means out of n things, out of n things, how many ways are there to select r things? How many possible ways are there to select r things? Two, and it's important to know it's select r things. Okay,
Yeah.
so let's think of some numbers and try to figure out what the meaning is. So if you have one thing and you have to select one thing, right?
Yeah.
You can do it in one way only, no?
One way.
Yeah.
And if you have one thing and you have to select 0 things, right? You
Yeah.
can do that also in one way. Don't select.
Okay.
Yeah.
You
Yeah.
understand? So
Mm-hmm.
if you have suppose 2 things and you have to select one thing out of it, right? You can
Yeah.
do it in 2 ways.
Two ways. Yeah.
2 ways. Yeah.
So that should be 2. And if you have 3 things and you have to select one thing, it will be done in how many ways? Out
Three.
of 3 things, you have to select one thing. You have 3 ways,
Three ways. Yeah.
Yeah.
right? So similarly, let's do it on the next page. So 2C2, out of 2 things, both the things you have to select, right? How many
Yeah.
ways are there?
One way.
One way,
1 way.
right?
Yeah.
And 3C2, let's think about this. You have 3 things, you have to select 2 things, right?
Again, three
How many?
ways.
There will be 3
3 ways.
ways
Yeah.
Yeah.
because one of the things has to be omitted, right?
Yeah.
So you can
Yes.
select which one gets omitted, right?
Yeah. Yeah.
That can be done in 3 ways, right? So similarly,
Yes. Yeah.
4C1, suppose 4C1 will be 4, obviously.
Yeah.
Yeah.
4C2, let's say A, B, C, D, you have to select 2 things, right? So let's write down what are the possible 2 things: AB, AC, AD,
Hmm.
BC, and BD,
BD. Then
and CD,
CD. Yeah.
right? So 4C2
Yeah.
should be 6, right?
Six.
4C2 is 6 because out of 4 things to select 2 things, there are 6 possible combinations, right?
Yeah.
Yes. Yeah.
So now, if you look at this table, now the Pascal's triangle will make a little bit of sense because now you see that this is 1C0. Okay.
Yeah.
1 second. You can ignore the top one. This is 1C0, this is 1C1, right?
Hmm.
So the second row is basically 1C0, 1C1, right? Both of them are
Yeah.
1, right?
Yeah. Yeah.
Yes.
Third
Yeah.
row is basically 2C0, 1, 2C1
1.
and 2C2.
Yeah, yeah.
And this row is 3C0, 3C1, 3C2, and 3C3.
Yeah,
Confirm for yourself that all of these will be this only.
yeah,
Yeah.
3C0
Yeah.
is 1, 3C1 is 3, 3C2 is 3, and so on, right?
yeah.
Next row, we already wrote the row to be this, right? And now see, this is 4C0,
Hmm.
4C1,
4C2,
4C2,
4C3.
4C3, and 4C4,
Hmm.
right?
Yeah,
Yeah.
Correct. You're getting this, no?
yeah, yeah.
Yeah. Yeah.
So right now, so far, we have seen the pattern of that Pascal's triangle. So Pascal triangles, the terms are coming as these terms are the values, right?
Yeah,
Yes.
Correct. The next term will be say 5C0, 5C1, 5C2, 5C3, 5C4, and last one will be 5C5 will be 1.
yeah,
5C0 is also 1. 5C1 is 5. 5C2 is 10. This is 5. This is 1. This is 5. No, no. I have made a mistake. Yeah? Oh, no. This is 10. This is 5. And this is
10, 10, 5.
10, 10, 5 it is.
Yeah.
Because 5C2 and 5C3 are same. So,
Hmm.
because
Yeah.
let's say you have A, B, C, D, E, right? So, suppose
Yeah,
you try to select two things out of this, right? 5C2, right? So
yeah,
you have to select two, right? So you can do AB, AC, AD, AE, right? Then you can do BC, BD, BE, CD, CE, DE, right?
yeah,
Yeah.
yeah.
10 are there, right?
10.
Yeah.
Correct. But while
Yes.
Yeah.
selecting these 10, already you have
We
excluded,
are ignoring 3.
you're ignoring three, right? And each
Yeah.
case, there will be a different three that you have ignored, right?
Hmm.
Yeah.
So there are 10 ways to, you can say that
Yeah,
by selecting two of them, I have also technically selected three of them, right?
yeah,
Hmm.
Three of them selection will be these, no?
yeah, yeah.
Yeah. Yeah.
You understand? While selecting two of
Yes.
them, you have left out the three. So that is a selection
3.
of those three, right?
Yeah,
Yeah.
Correct. So 5C2 will be equal to 5C3. And that is a general property that NCR will be equal to NC n minus R.
hmm.
Okay, that is a general property. Okay. So
Yeah.
now one second. Uh, just hold on for a moment. Correct. So now what we need is a way to find the value of say 7C4. Okay.
Mm-hmm.
7C4. So right now we don't want to actually list down all the possible ways, right? That will be too long.
Yeah, yeah.
Yeah.
We don't want to list down. So 7C4 or NCR is basically defined to be this: n factorial by r factorial n minus r factorial. In factorial notation, you know the meaning, right?
Yeah.
Yeah.
So n factorial by, so this one will be what? 7 factorial by 4 factorial and 3
Into
factorial,
3.
right? So the
Yeah.
value of this will be 7 into 6 into 5 into 4 into 3 into 2 into 1, right?
Yeah,
But that part can be written as 4 factorial, right?
yeah.
By 4 factorial and 3 factorial. So 4
Hmm.
factorial gets
4
cancelled.
factor.
3 factorial is equal to 6. So that gets cancelled. So this is 35.
Yeah.
And remember, there was 35 in one of the seventh row that we had written. No?
Hmm. Hmm.
1, 7, then there was some 21, and then 35, and then 21 and stuff, right?
Yeah.
You
Yeah.
remember
Yeah, yeah.
when I was writing the Pascal triangle, there was a 35 and 21 coming.
Yes.
Yeah.
Yes. Yeah.
That was because in the seventh row, you'll have the 7C4 term, right?
Ah.
Yeah.
So the way to find the NCR is simply n factorial by n minus r factorial by r factorial. And that you can simplify, right? Obviously, you can write n, n minus 1, n minus 2, so on till n minus r plus 1. And then it is n minus r factorial, right?
Yeah, yeah.
So that gets cancelled from the denominator. And in the denominator, you have r r minus 1, r minus 2, so on till 1, right?
One.
Yeah.
Yeah.
This is the value of your NCR, right?
Hmm.
So now, because we have seen a relation between Pascal's triangle and binomial theorem coefficients, right? So now we can write that x plus y power n is going to be, so what was the first coefficient? NC0, right?
NC0. Yeah.
It will, first
Yeah.
term used to be x power n, right?
Yeah.
And then the terms were going to decline in powers of x and increase in powers of y, right?
Hmm. Yeah.
Yes.
Second term would be x power n minus 1 y. Third term would be NC2. So I'm writing the coefficients now, right?
Hmm. Hmm.
These are the
Yeah.
coefficients in the Pascal triangle, right?
Yeah.
And this term would be xn minus 2, y2, and so on, right?
Yeah.
Correct. And so on, you go on till you get n minus 1, for example, and this term becomes 1, and this term becomes n minus 1. And then you go to ncn y
Hmm. Hmm.
power n, right?
Yeah.
So this is the expansion. This is the binomial theorem expansion. Okay.
Yeah. Yeah.
So now uh, what we will do is write the general term for this binomial theorem. So x plus, okay, first we'll also try to understand why this NC0 and all is coming, right?
Hmm.
So let's try to write it like this: x plus y, and product how many times? N times, right?
Yeah.
N factors like this, right?
Yeah.
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 Correct. So let's focus our attention on the term x power n, right? So
Yeah.
when you multiply it out, finally x power n has to come, right?
Yeah. Yeah.
So how will you ever get a x power n, right? The way you will get an x power n is to select uh, all the factors and pick x from each, right?
Yeah.
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 Only multiply it with the x part, right? And keep
Hmm.
multiplying,
Yes.
right?
Yeah.
But there
Hmm.
is only one way to do that, no?
Yeah. Yeah.
How many ways are there to get that x power n, right?
Yeah.
Yeah.
Only
From
one.
each factor, you have to select only x. There is no choice available, right?
Hmm. Hmm.
Yeah.
Right. So there is only one way to do that. Select x from every factor and multiply it out, and you'll get 1 into x power n, right?
Yeah. Yeah.
Yeah.
Suppose now you have to get the term x power n minus 1 y, right?
Hmm.
Right. Now,
Hmm.
what does this mean? This means that out of the n factors, you have to select n minus 1 brackets from where you will choose x, right?
Yeah. Yeah.
And one bracket you have to choose for y, right?
One. Yeah.
Correct. So
Yeah.
what I mean is, suppose you have x plus y, x plus y, x plus y, right?
Hmm. Yeah.
Suppose I selected this bracket, I will take an x, this bracket, I will take an x, right?
Yeah.
This and this I'll multiply, and let's say I multiplied with a y, then I will get an x square y term, right?
X square y. Yeah.
But I could have selected this bracket and this bracket as x and this as the y, right?
Hmm. Yeah.
Will
Yeah.
give
Yeah.
another
Yeah.
x square y. And I could have selected this bracket and this bracket as x,
Yeah.
this one
Yeah.
as y, right? And that will give
Yeah.
another x
Yeah.
square y, right? So there are
Hmm.
basically three ways
Three. Hmm.
in which you could have gotten the x square y term, right?
Yeah.
That's
Yeah.
why you got a 3 coefficient there, right?
Yeah. Yeah.
So the idea is that here, what do you have to select? You have to select one y from these n brackets, right?
Hmm.
And the remaining brackets will be x, right?
Yeah. Yeah.
So that's why the coefficient is out of n brackets, select one y, right?
Hmm.
So that's why it is nc1,
And
right?
see. Yeah.
So it is nc1 here, and you can say this is nc0 because you're selecting how many y's?
Zero.
All the brackets you are selecting x only, right? So there are zero
Yeah.
y's. So nc1, the value of nc1 used to be n, right?
And yeah.
Yeah.
Correct. So that's why the coefficient comes as nc1, right?
Hmm.
So you understand, when you make any arbitrary term, right? You make this term, for example. So that means to make this term, you have to count how many ways this term can come, right?
Hmm. Hmm.
Yeah.
This
Yeah.
can come out of the n brackets, you have to select r times, you have to select y, right?
Yeah.
So therefore ncr times y, and the remaining will be obviously x's, right?
Yeah. Yeah.
You understand?
Hmm.
So that's why these ncr terms and all are appearing, right?
Yeah.
Correct. So now we can write x plus y power n general term as summation of r goes from 0 to n ncr x power n minus r and y power r, right?
Yeah.
So this is a compact version of the same binomial theorem, right? This is
Yeah.
saying
Yeah.
keep varying your r, and this is going to be nc0 x power n y power 0 plus nc1 x power n minus 1 y power 1 and so on, right?
Yeah.
Till
Yeah.
ncn x power 0 y power n, right?
Yeah.
So this is also binomial theorem, correct?
Hmm.
Okay, so now that we know this expansion, now we can start by solving some basic questions of some examples we'll do. So remember your binomial theorem expansion is this, okay?
Hmm.
Yeah.
R is equal to 0 to n ncr x power n minus r. First term is n minus r and second term is
Y
r,
power R.
right?
Yeah.
So
Yeah.
r will match the second term's coefficient power, right?
Yeah.
And you know the definition of ncr is equal to n factorial by r factorial n minus r factorial. You should know that by definition,
Hmm.
0 factorial is equal to 1 factorial is equal to 1. Okay.
Yeah. Yeah.
And other factorials, you know how to do it,
Yeah. Yeah.
right?
Yeah.
So now the question is, one second. Uh, just hold on for a bit. Correct. So first question is, in the expansion of uh, 1 plus x to the power m, 1 plus x to the power m, and 1 minus x to the power n, right? Okay.
Yeah.
The coefficients of x and x square, the coefficients coefficients are the terms that are the numbers, right?
Yeah.
Yeah.
Coefficients of x and x square are basically coming out to be 3 and minus 6, are 3 and minus 6 respectively. Okay,
Hmm.
you have to find the value of m. Find m. This is the actual JEE 1999 question. It's an objective question, 2 marks. The second question is, uh, find the coefficient of x power 7. Find the coefficient of x power 7 in the expansion of ax square plus 1 by bx to the power 11. Okay, so
Yeah.
by coefficient, everyone understands coefficient meaning. No,
Yeah.
coefficient was
Yeah.
this,
Yeah. Yeah.
the number that accompanies the term, right?
Yeah.
Yeah.
So using binomial theorem, try to solve these two. Okay, take 5 minutes. I'll be back in 5. Okay, any ideas for the first one?
Mm, 1 second.
Yeah. So here, uh, we know how to expand each of them, right?
Yeah.
So
Yeah.
suppose you had been given the question, just expand this, right? So you would have done what? You would have done, uh, this is summation of r goes from 0 to m, mcr, 1 power m minus r, right?
Yeah. Yeah.
To x power r, right?
Yeah.
So this is basically just summation of r is 0 to m, mcr x power r, right?
Yeah. Yeah.
So that can be written as mc0 x power 0 plus mc1 x power 1 plus mc2 x power 2 and so on, right?
Yeah.
mc3 x power 3 and so on, right?
Yeah.
Till mcm x power m, correct?
Yeah. Yeah.
And if you had
Yeah.
written the expansion of 1 minus x power n, right, that would have come, r is 0 to n now because power is n, and it would have been nc0 1 power n minus r and minus x to the power r, right?
Yeah.
Correct. So that becomes summation r is 0 to n, this is not nc0, this is ncr, right?
Yeah. Yeah.
This is ncr. This is minus 1 to the power r and x power r, right?
Yeah.
So when you write down the terms, first few terms, it will be nc0 minus 1 to the power r, so minus 1 to the power 0, x power 0 plus nc1 minus 1 to the power 1 x power
Yeah.
plus nc2 minus 1 whole square
So
x
plus
square
minus plus.
and so on, right?
Yeah.
Correct.
Yeah.
So actually you have two different series and you have to multiply them, right?
Yeah.
And the terms here are mc0 is 1, right?
Mm-hmm.
mc0 is 1, so it is 1 plus m into x, right? mc1 is
Yeah.
m plus this thing mc2x squared, mc2x squared, right?
Yeah.
Plus
Yeah.
some other terms. The other terms have higher powers, that's why I'm not
Yeah.
writing them.
Yeah.
Here the second series is 1 minus n into x, right?
Mm.
Plus nc2 x square minus so on so on,
Yeah.
right? So this is the product of two different series, right?
Yeah.
Now when you
Yeah.
multiply the series, you will get the final series which will have these terms, right?
These terms. Yeah.
So
Mm.
how can you get x term? So let's focus our attention on the x term only, right?
Mm.
So for the x term, I can do 1 into minus
1 into
nx, right?
that and mx into
Minus
1.
nx plus mx into 1, right?
Yeah.
Yeah.
Is there any other way you can get x terms?
No, no.
No.
Because anything else is higher power, no?
Yeah.
Yeah.
So the x term can come only in this way, right? So it will be m minus n into x, right?
Yeah.
M minus n must be the coefficient.
Yeah. Yeah.
Yeah.
M minus n is equal to 3, right?
Yeah. Yeah.
And
Yeah.
for the
Yeah.
x square term, how will you get? You can do mc2 into 1, right?
Hmm.
mc2 into 1 x square, and you can go do nc2 into 1 x square,
Yeah. Yeah.
and you can
Yeah.
do one more term which is x into
MX.
x
Yeah. Exactly.
minus mn x square.
Yeah.
There is no other possibility now,
Hmm.
because other
Yeah.
terms are having powers of x cube and stuff, right?
Yeah.
So this becomes mc2 plus nc2 minus mn, right, into x
Yeah.
square. So this is the term. So this must be equal to minus 6, right?
Yeah. Yeah.
Yes. Yeah.
This thing is equal to minus 6 and m minus n is equal to 3. Now you have to solve these equations, right,
Yeah.
to find m and n. So let's just solve them. So m minus n is equal to 3, and the second equation is this. So you have m minus n is equal to 3. The second equation is mc2 plus nc2 minus mn is equal to minus 6, right?
Yeah.
Yeah.
mc2, if you do, it is m factorial by m minus 2
M minus
factorial
2.
2 factorial, right?
Yeah.
So that will be equal to m into m minus 1 into m minus 2 factorial, which gets cancelled
Cancelled. Yeah.
by 2, right?
Hmm.
So
Yeah.
similarly, nc2 will
And
also be that
same thing. Yeah.
m into m minus 1 by 2 plus n into n minus 1 by 2 minus mn is equal to
Yeah.
minus 6, right?
And then just substitute for.
So now what you can do is you can just put m is equal to n plus 3.
Yeah.
You can put m is equal to n plus 3 in this equation, right?
Yeah. Yeah.
Correct. So
Yeah.
this becomes n plus 3 into n plus 3 minus 1. So n plus 2 by 2 plus n into n minus 1 by 2 minus n plus 3 into n is equal to minus 6, right? So
Yeah.
this becomes n square plus 5n plus 6 plus n square minus n by 2
Yeah.
minus n square plus 3n is equal to
Yeah.
minus 6.
Yeah.
This
Yeah.
becomes 2n square divided by 2 becomes n square. N square plus 4n by 2. So 2n
2n.
plus 6 by 2. So plus 3 minus
Yeah.
n square minus 3n is equal
Yeah.
to n square cancels. Minus n is equal to minus 9, right?
Minus that.
N is equal to 9
M
and
is 12.
m must be 12, right?
Yeah. Yeah.
Yeah.
Correct. So it's just solution of equations after that. The whole point was being able to write this, and decide what the coefficient of x and x square should be, right?
Yeah.
Yeah.
Correct. Second question was coefficient of x power 7 in the expansion of ax square plus 1 by bx to the power 11. Okay. So here in the second question, again write the general term of the binomial series, right?
Yeah.
Yeah.
So your binomial series will look like ax square plus bx plus 1 by bx to the power 11. When you expand, it should be summation of r goes from 0 to 11, right?
Yeah.
Yeah.
And it should be 11 cr and first term to the power n minus r, right?
Yeah. Yeah.
11
Yeah.
minus r and second term to the power r, right?
Yeah. Yeah.
This is my general term, no?
Yeah.
Here r can vary, so this term is called the general term, right?
Yeah.
So 11 cr, let's simplify it a little bit. A power 11 minus r into x power 22 minus 2r, right? Into
Yeah.
1 by b power
B
r
power
x
R
power
and
r,
X power. Yeah.
right? So this
Yeah.
becomes 11cr a power 11 minus r by b power r and x power 22 minus 3r, right?
Yeah.
This is my general term, right? And in this general term, I have to keep varying my r, right? From 0 to 11, right?
Yeah. Yeah.
Yeah.
And you will get all the terms, right? So
Yeah.
now we don't have to write all the terms. We have to find the coefficient of x power 7, right?
Seven. Yeah.
So when
Mm.
x, this power becomes 7, that time we have to find the coefficient, right?
Wow.
Yeah.
So we
Yeah.
can say that x power 22 minus 3r has to become x power 7. So what should be my 22 minus 3r? It should be 7.
Seven. Yeah.
So you
Yeah.
get
7.
15 is equal to 3r. So
Yeah.
r
Five.
is
Yeah.
5, right?
Yeah.
Yeah. So 11C5.
So it will be
C
11c5
five. Yeah.
a
Yeah.
power 6 by b power
Power
5.
five. Yeah.
Correct. So this is the coefficient
Mm-hmm.
of x power 7. Okay.
Yeah.
Yeah.
So in general, most of the binomial theorem questions will be solved by thinking about the general term and figuring out from there, right?
Yeah.
So
Yeah.
now let's see some special cases. So we know that this series is written as r0 to n ncr x power n minus r y power r. So some special cases of this binomial theorem are more important. So you could have 1 plus x to the power n, right?
Yeah.
This series is very important. It comes many times. That's why. So that can be written as r is 0 to n. First
Mm.
term ncr into first term is 1. So that is nothing, right?
Mm.
First term, whatever power you raise doesn't change anything.
Yeah.
Second term is to the power r, right?
Yeah.
So this is the series, right?
Yeah. Yeah.
So when you write it out, when you expand it, it becomes nc0 plus nc1x plus
Mm.
nc2x square plus nc3x cube, right?
Yeah.
And
Yeah.
so on till ncn x power
X.
n, right?
Yeah.
Yeah.
Sometimes when you write the combinatorial coefficients, you don't write nc0, you sometimes just call it c0. It is
Mm.
understood that there is n on top.
Yeah. Okay.
So that is just a shortcut way of writing. So many times you will see people writing it like this: 1 plus x, this is equal to c0 plus c1x plus c2x square and so on,
Yeah. Yeah.
Yeah.
plus cnxn, right?
Yeah.
Which is
Yeah.
basically 1 plus nx plus n into n minus 1 by 2x square plus n into n minus 1 n minus 2 by 1
Yeah.
into 2 into 3 x cube and so on till x power n.
Mm. Yeah.
Here
Yeah.
I've just put the values of c1, c2, c3 and so on.
Mm-hmm.
Okay.
Yeah.
So this is a standard form. Okay. This is an important form to know, that this is a special case of x plus y to the power n. Now in case you
Mm-hmm.
had 1 minus x to the power n, right? That would be just
Mm.
nc0 minus nc1x plus nc2x square minus nc3x cube plus nc4x4 minus nc5x5 and so on, right? You see the pattern?
Yeah. Yeah.
Yeah.
All
Yeah.
odd powers will become a negative, right?
Negative.
Yeah.
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 And all the even powers will remain positive. Correct?
Yes, sir. Yeah.
Okay, so these are important things to know. Then let's do one more question. Uh, question is, find the value of find the value of uh, 18 cube plus 7 cube, 18 cube plus 7 cube plus 3 into 18 into 7 into 25 divided by 3 power 6, 3 power 6 plus 6 into 243 into 2 plus 15 into 81 into 4, 15 into 81 into 4 plus 20 into 27 into 8 plus 15 into 9 into 16 plus 6 into 3 into 32. 6 into 3 into 32 plus 64. Now, this is a very easy question. It's just that you need to recognize what is happening. Someone found the answer, tell me.
It's 1, right?
Hmm. It is 1. It is obvious why, right?
Yeah.
The top part becomes 25 cube, everyone can see.
Yeah, it's 18
Yeah,
plus 7
yeah.
power cube.
It is
Yeah.
Oh,
18
and the
cube.
bottom 3 plus,
3
yeah,
plus
5
2
plus
power
6,
cube.
6.
Yeah.
3 into 18 into 7 into 18 plus 7, right?
Yeah.
And
Yeah,
bottom is the binomial expansion of 3 plus 2 to the power 6.
yeah, yeah.
See, this is 6c1, right? And this is 3 power 5. This is 2 power 1.
Yeah. Yeah.
And this is 6c2 is 15, and 3 power 4 is 81, and 2 square is 4, right?
Yeah.
All the terms are coming here.
Yeah. Yeah.
Yes, yeah.
6c4, 3 square, and 2, 4. 6c5, 3 power 1, 2 power 5, and 6c6 into 2 power 6, right? So numerator is 25 cube and denominator is 5 power 6, which is equal to 1, right?
Yeah.
So very straightforward. Then let's look at this question. Find the number of rational terms. Find the number of rational terms in the expansion of 9 power 1 by 4, 9 to the power 1 by 4 plus 8 to the power 1 by 6 to the power 1000. You have to find rational terms there, because some terms could be irrational, right? Right now, this is irrational because it's actually root 3, right?
Yeah.
And this is root 2. Basically, the expansion is root 3 plus root 2 to the power 1000.
Mm-hmm.
You have to find the number of rational terms in this expansion. So write any general term of this series, right? That would be 1000 CR root 3 to the power 1000 minus r and root 2 to the power r, right?
Yeah.
Yeah.
Correct. So you get 3 to the power half, so it is 500 minus r by 2 and 2 to the power r by 2, right?
Yeah. Yeah.
And 1000 cr, right?
Hmm.
That is
Yeah.
any arbitrary term in this series, right?
Yeah.
R can obviously go from 0 to 1000,
Hmm. Hmm.
right?
Yeah.
So
Yeah.
to make it rational, what do you have to make? You have to make this an integer and this an integer,
Yeah. Yeah.
Hmm.
correct? So
Yeah.
then
Yeah.
only it will be rational. No? If it's a fraction, it will not work.
Yeah. So
So
like multiples of 2 and
Yeah.
0.
correct. So you can get, if r is 0, it is rational.
Hmm.
R is 0, it is rational. And it to get 2, then also it's fine, right?
Yeah.
Yeah.
1 is not fine, right?
So even.
All the even numbers will be fine. No?
Yeah.
Yeah.
Till is
Till
1000 fine?
1000.
1000 is also fine.
Yeah.
All the even numbers from 0 to 1000. So these are 500 terms because 2 into 1 and this is 2 into 500.
Hmm. 501
So
total.
total is 501, correct?
Yeah.
Yeah.
501 terms in this expansion are rational. Total number of terms in the expansion was 1001
Hmm.
Hmm.
because n power is 1000. So number of terms should be 1001, right?
Yeah. Yeah.
Total
Yeah.
number
Yeah.
of terms were 1001, out of which 501 were rational.
Hmm.
The remaining
Yeah.
would be irrational.
Yeah.
Okay. Then we will discuss something called middle term. Middle term is very obvious. Uh, so if you have x plus y to the power 4, right? How many
Hmm.
terms are there? There are 5 terms, no?
5 terms. Yeah.
Yeah.
So there is only one middle term there, right? Because 1, 2, 3, 4, 5. Third term will be middle term, no?
Yeah. Yeah.
Right? Correct.
Yeah.
Yes.
Because there are odd number of terms total. So two from this side, two from that side, right? So middle
Yeah.
term is this third term, right? So third
Yeah.
term, how will you write third term? Third term. Third term will be when r is equal to 2, right?
Yeah.
Yeah.
Because r starts from
0 to
0,
4.
right?
Yeah.
0,
Hmm.
1,
Yeah.
2. The third term is r is equal to 2, right?
Yeah.
So remember always that if you want to find, say, term 5, right?
Hmm.
Or fifth term, right? You will have to put nc4, x power n minus 4, y power 4, right?
Yeah.
Hmm.
Fifth term is not nc5 term, that is sixth term, right?
Yeah. Yeah.
Yeah.
So remember that, don't make that mistake. So third term will be when n is equal to 2. So this will be 4c2 and x power 2, y power 2, right?
Hmm. Yeah.
4 to c2 is 6. So 6x square, y square is the middle term,
Hmm.
correct?
Yeah.
However, if you have x plus y to the power 5, right? How many terms are there? 6, right?
6. Hmm.
So then now you cannot split it properly, right?
Hmm. Hmm.
There is no one term that is middle term. You will say that both these terms are called
Yeah.
middle terms.
Yeah. Yeah.
So when the power is odd, the number of terms becomes even. So then there is no one term that is the middle term. There are two
Hmm.
terms which are called middle terms, right?
Yeah.
Yeah.
Term number 3 in this case and term number 4 in this case, right?
Yeah. Yeah.
Hmm.
So term number 3 means r value is 2 and term number 4 is r value is 3, right?
Yeah.
So what is r value 2? It will be 6c2, right? X power 4, x power 5
6.
minus,
5.
oh, it should be 5.
5C5.
It should be 5c2,
Yeah.
x power 3, y power 2, right?
Yeah.
And it should be 5c3,
5C3
x
X
square
square
y
Y
cube.
cube. Yeah.
And
Yeah.
5c2 is equal to 5c3 is equal to 10.
10. Hmm.
So both these terms are called middle terms. in this case, correct?
Yeah.
Yeah.
So that is the concept of middle term. So in case in situations where the power is even, there is only one middle term, and in situations when power is odd, there are two middle terms.
So, yeah.
Yeah.
That is some straightforward stuff. Then we will go ahead. Let's look at some properties of the binomial coefficients. So properties of binomial coefficients. Binomial coefficients, by that we mean NC0, NC1, and so on.
Yeah.
NCR, right? So the first thing we will see is NC0 plus NC1 plus NC2 plus NCN is equal to 2 power n. Okay. This can be proved very easily by looking at the expansion of 1 plus x to the power n, right? 1 plus x to the power n we did earlier. It was a standard
Yeah.
expansion called NC0 plus NC1x plus NC2x square plus so on till NCN x power n, right?
Yeah.
Yeah.
If
Yeah.
you put x is equal to 1 in this identity, what do you get?
Yeah.
You get the summation, no?
Yeah. Yeah.
Correct. And this side becomes
1
2
plus
power
1.
n, right?
Yeah.
So 2 power n is C0 plus C1 till Cn, right?
Yeah.
Yeah.
Correct. So, are you sure you understand?
Yeah. Yeah.
Yeah.
Similarly, what is the value of C0 minus C1 plus C2 minus C3 and so on till minus 1 to the power n Cn, right? Suppose you have to
Yeah.
find this value, right?
Yeah. So
So then we had seen the series 1 minus x to
B0.
the power
Yeah.
n, no?
0. Yes.
Right?
Yeah.
This was
Yeah.
this, right?
0.
So when you put x is equal to 1 here, you will get left hand side becomes 0, right? 0 is equal to C0 minus C1 plus C2 minus C3 and so on, right?
Yeah.
Yeah.
Correct. So that implies the two relations together now imply that C0 plus C1 plus C2 till Cn was equal to 2 power n, and C0 minus C1 plus C2 minus, correct, will
Yeah.
be equal to 0,
Yeah.
right?
Yeah.
Hmm.
If you add the two together, what do you get? 2 times, correct?
Yeah. Yeah.
You are cancelling out all the odd terms, right?
Yeah.
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 And all the even terms will remain when r is 0 or 2 or 4, correct?
Yeah. Yeah.
Yeah.
You have proved that C0 plus C2 plus C4 plus so on till whatever term is the last term, right? Even last term, right? That will be equal to 2 power n minus 1, right?
Yeah. Yeah.
Yes. Yes.
And if that much was equal to 2 power n, then the remainder should also be equal to 2 power n, right?
Yeah. Yeah.
So you also have C1 plus C3 plus C5 plus so on till is equal to 2 power n minus 1, correct?
Hmm.
Makes sense.
Yeah.
Why is the odd term also equal? Because you can just simply uh, isolate all the odd terms, right?
Yeah.
The
Yeah.
isolation will become,
Yeah.
it is 2 power n minus 2 power n minus 1, which is 2 into 2 power n minus 1 minus 2 power n minus 1, which is correct.
Yeah.
Hmm.
Yeah.
Yeah.
So we get some nice results here. Then, for example, uh, let's try to find out the value of this, correct? This value. Okay.
Yeah.
So right now, what do we know? We know C0 plus C1 till Cn is equal to 2 power n, right?
Yeah. Yeah.
We
Yeah.
know C0 minus C1 plus 1 is equal to 0. These things we know. We also know
Yeah.
that the binomial theorem expansion of 1 plus x power n is c0 plus c1x plus c2x square and so on till cn x power n, right?
Yeah.
The job is to find the squares of the coefficients and sum of squares for all of them, right?
Mm-hmm.
Yeah.
Okay.
Yeah.
Think about it. See if you can figure it out. I mean, it is not obvious, so maybe I should only tell. Uh, so this we need, right? Okay. So tell me what the expansion of this will be. What is the expansion of this? If I had just
So
reversed the terms,
reverse.
no?
Yeah. Yeah.
It should have started with C0 x power n, right?
Yeah.
And 1 power 0, right? Then
Mm-hmm.
C1 x power n minus 1, right?
Yeah.
Yeah.
Plus C2 x power n minus 2, right?
Yeah.
Till final term will be Cn into 1, right?
One. Yeah.
Correct.
Yeah.
Now look at these two series together. Okay.
Mm-hmm.
If I multiply this one, this bracket with this bracket, right?
Yeah.
If I multiply this bracket with this bracket, what is my result coming? What is the first term?
C
C0
naught
square
square xn.
x power n. Then this one will be multiplied. This
Yeah.
one
So
will be
C1
multiplied and
square.
so on, right?
Yeah.
But I don't
Yeah.
care about those terms, okay? I don't want to find that value, right?
Uh-huh.
I don't want to find C0, C1, C0, C2 stuff, right?
Yeah.
Yeah.
Let's ignore those terms for now. I'll focus my attention on the square terms, okay? If I
Yeah.
multiply
Yeah.
this one and this one, what happens?
C1 square
C1 square x
x to
power
power
n.
n. Yeah.
And if I multiply this one and this one,
C2 square.
x power n.
Yeah.
And so on, you get Cn square x power n also, right?
Yeah.
Correct.
Yeah.
Now tell
Yeah.
me, is there any other way to get x power n? When you multiply this term and this term, total number of terms should be how many? Tell me.
2n.
Oh no.
Wait. It's,
This is how many terms?
that's n plus 1. Yeah.
And this is n plus 1. So number of terms should be,
N plus 1 square. Yeah.
right?
Yeah.
These many terms should come, right?
Yeah.
Right now, out of those n plus 1 square terms, I have found these many terms. This is n plus 1, right?
N plus 1. Yeah.
N plus 1 terms out of those n plus 1 whole square terms, right?
Yeah.
Which have the coefficient x power n,
X
x
power
power n,
n.
x power n, right?
Yeah. Yeah.
Now
Yeah.
think about it. Is it possible to get any other x power n? Can you multiply C0 with something else and get x power n?
No. No.
No.
Only this, right?
Yeah.
Similarly, C1 x power n you cannot get through any other way, right?
Yeah. Yeah.
Right? Because here the power is becoming bigger, here the power is becoming smaller, right?
Yeah. Yeah.
Yeah. Yeah.
You understand? So if you think about it, you will realize that this is the only possibility of getting x power n, right?
Yeah.
Yeah.
So you can say that C0 square plus C1 square common till Cn square into x power n, right? That is one term, right?
Yeah.
That is one term with x power n, right?
Yeah. Yeah.
Yeah.
When you multiply these two sides, right?
Yeah.
The right hand side of both the equations, right? So the left hand
Yes.
side is what? Left hand side is obviously 1 plus x to
1
the
plus
power
n.
2n, right?
Yeah.
Because the order doesn't matter really.
Yeah. Yeah.
It's 1 plus x to the power 2n, right? So left hand side will be a series with how many terms?
2n plus 1.
2n plus 1 terms, right?
Yeah.
And it will
Yeah.
have powers of x going from x power 0 till x power 2n, right?
Yeah. Yeah.
Yeah.
Correct? So if we say left hand side, what is the coefficient of x power n, right? That should match right hand side coefficient of
Yeah.
x power
Yeah.
n. No?
Yeah.
Yeah.
Both sides, the coefficient of x power n must match, right?
Match. Yeah.
And
Yes.
what I have ensured by taking this reverse series and multiplying is that this side The coefficient of x power n came as the thing that we wanted to find,
Yeah, yeah.
right? And this side, finding coefficient of x power n here is not hard at all. 1 plus
Mm-hmm.
x to the power 2n, I will
Yeah.
write general term as 2n cr, 1 power 2n minus r, and x power r, right?
R, yeah.
So what will happen when this will become x power n? When r is equal to
R
n,
is equal to N.
so the coefficient will be what?
C2 and
2n cn.
yeah.
So the answer is equal to 2n cn.
Oh,
You understand?
yeah.
How did we do it? We got it by checking,
Nothing good.
selecting a different binomial series and trying to get this as a coefficient of some term, right?
Yeah, yeah.
Notice that
Yes,
if I
yes.
had not reversed it, no, if I had not reversed it, it would not work out so easily.
Mm-hmm.
Because then when you multiply, the powers keep rising, no?
Yeah, yeah.
If I had written the same thing once more, right? And I had not
Yeah,
reversed it, then what would have happened? C0 square into 1 plus C1 square into x square, right?
yeah.
Plus C2 square into x power 4, right?
Yeah, yeah, yeah.
So then there is pointless, no? Because there is no common coefficient, right?
Yeah,
Yeah,
The term that we are seeking, the value that we are seeking is not having a common x power something, right?
yeah,
It's having
yeah.
different x powers, right? That doesn't help us a lot, right?
yeah,
Mm.
But after reversing it, when we multiplied, it came out very nicely, right?
Yeah, yeah.
All of the terms had the same power, so we were able to find that particular power in the left hand side also, right?
Yeah, yeah.
So the thing that we have derived is, third result is c naught square plus c1 square till cn square is equal to 2n cn, right?
Yeah.
Now let's just confirm it for ourselves. If you get c0 square plus c1 square plus c2 square, right?
Mm.
And let's say n is equal to 2, right?
Okay.
Correct. So let's find the value of this. According to our prediction, it should be 4c2, right?
Yeah,
Correct.
yeah.
yeah,
So let's find this. 2c0 is actually 1, right?
Hmm.
1
Yeah.
square plus 2c1 is 2. So this is
Two
4
square, four.
and this is 1. So this is actually
Yeah.
coming out to be 6 and
Six.
4c2
Yeah.
is 6.
Six. Mm.
yeah,
Okay.
yes,
It will work. This is correct, right?
Yeah.
So now next thing that we want to find is find Ci Cj summation 0 is less than equal to I less than j less than equal to n. What this
Mm-hmm.
means is basically terms like this: C0 C1 plus C0 C2 plus C0 C3 plus so on plus C1 C3 plus C1 C2 plus C1 C4 plus C1 C5 and so on, right?
Yeah. Yeah.
Basically all the products taken two at a time, right?
Yeah. Yeah.
yeah,
Like when you have alpha plus beta plus gamma as roots of some equation, you can find alpha beta beta gamma alpha gamma, right? This is the things taken two at a time, sum of the products, right?
Mm-hmm.
yeah,
Similarly, what I want is ci cj taken two at a time, that sum, right?
Yeah. Yeah.
There will be many terms obviously, but you have to find all the two at a time terms, right?
Yeah. Yeah.
Where I and j are not equal. Okay, if I and j are equal, it will come as this one, right?
Mm-hmm.
Correct.
Yeah.
yeah,
Yeah.
So I and j cannot be equal. That is that summation we need to find. Okay. So for this summation, for example, what we will do is, we know this result, right? C0 plus C1 plus C2 plus Cn is equal to 2 power n, right?
Mm.
yeah,
Yeah.
And now we also know one more thing: C0 square plus C1 square plus Cn square is equal to 2n Cn, right?
Yeah. Yeah.
So now this looks like the, if you had squared it, right, you would have gotten these terms plus
Yeah. Plus the.
2 times the double summation, right?
Yeah.
You understand what I'm saying?
Yeah. Yeah.
So
yeah,
if I had written alpha plus beta plus gamma whole square, right?
Mm.
I would have gotten alpha square plus beta square plus gamma square plus,
Plus 2 times alpha, beta, beta,
uh,
gamma, alpha.
it would have been alpha square plus beta square plus gamma square plus 2 times the double summation, right?
Yeah,
Yeah.
Terms like this, right?
yeah,
So that same logic we'll use. So if you have this much square, right? So this becomes 2 power 2n, right?
2n, yeah,
And that should be equal to c0 square plus c1 square plus some stuff plus cn square, all the individual squares plus 2 times double summation of ci cj, right?
yeah, yeah,
Is equal to 2 power 2n, right?
yeah,
And we
Yeah.
know this is 2n cn. So this double summation ci cj should be equal to 2 power 2n minus 2n cn
yeah,
divided by 2, right?
2, yeah.
Correct. This becomes
Mm-hmm.
2 power 2n minus 1, 2 power 2n minus 1 minus half of 2n cn. Correct?
Yeah,
Yeah.
You are understanding how we got it, no?
yeah, yeah,
You can check it for some small values and see if it is working out or not. Okay. Uh, then some identities, some more identities. Let's see this one. NCR plus n minus 1 CR is equal to n plus 1 CR. Okay.
mm.
So this identity actually, think about it. You can prove it by simple algebra. Okay.
Mm.
Take the definition.
Yeah, yeah.
Take the
N
definition n
factorial,
factorial by n minus r factorial
factorial.
plus
Mm.
n minus 1 factorial by r factorial n minus r minus 1 factorial, right?
Yeah.
1 second, let me just check the identity if it is correct. Oh, I made a mistake in the identity. This is wrong. 1 second. Uh, the identity is NCR plus NCR minus 1 is equal to n plus 1 CR. Okay.
Mm-hmm.
Now let's try to prove it. N factorial by n minus r factorial plus n factorial by r minus 1 factorial n minus r plus 1 factorial, right?
Yeah.
Take common stuff, n factorial common, r minus 1 factorial common, right? And n minus r factorial common.
Mm-hmm.
What is left here? 1 by n minus r factorial is taken out. 1 by r is left here, plus
Yeah, yeah,
1 by n minus r plus 1 is left here, right?
yeah,
Yeah.
This becomes equal to r into n minus r plus 1, and on top becomes n minus r plus 1 plus r. So n plus 1, right?
yeah, yeah.
So when you multiply n plus 1 into n factorial, top part becomes n plus
N
1
plus
factorial.
1 factorial.
And when you multiply r and this, it becomes r
R
factorial.
factorial.
And when you multiply this and this, it becomes n minus r plus 1 factorial, right?
Mm.
Now notice that this is similar, exactly that,
Yeah,
correct? N
Yeah.
minus r plus 1 factorial, right?
yeah, yeah.
So by algebra, you can just prove it. However, this identity is super important. So we will try to understand a different way of thinking about it also, which will help you remember it.
Mm.
Okay.
Okay,
So
okay.
this is an important identity. You need to remember this. So the way to think about it is very simple actually. This is an identity that comes from Pascal's triangle.
Mm-hmm.
So think of the Pascal triangle. What was the logic of forming the rows, right? What is 1 plus 2 was 3, no?
Yeah.
What is this? This is
Mhm.
2C0,
C0,
and this was 2C1
2C1,
is equal to 3C1.
3C1. Yeah,
Yeah.
Two elements in a row side by side will have r minus 1 and r, no?
yeah, yeah.
And the next row below that will be n plus 1 CR.
Mm. Yeah,
This is the basic rule of forming the Pascal's triangle. Okay.
Yeah.
So
Yeah.
notice this and this, right? This one was what? 3C2, 3C1 and 3C2,
3C1,
right?
3C2. Yeah.
3C1, 3C2, and addition was what?
3,
Should be
4C2.
4C2.
Yeah.
You understand?
Yeah.
Yeah.
So 3C1 plus 3C2 is 4C2, right?
Yeah. Yeah.
Because Pascal's triangle. These are adjacent terms in one row of a Pascal's triangle, right?
Hmm.
So the addition of two adjacent terms will give the term below it, right?
Yeah. Yeah.
Yeah.
So you go to the next row, it will become n is equal to 4, right?
Yeah.
Correct. And the higher term here becomes the 2. You understand? The higher value
Yeah.
becomes
Yeah.
the 2, right? So this is just
Yeah.
Pascal's triangle identity. Okay. So if you are confused, think of if you are confused whether it is n minus 1 CR or whatever, right?
Mm-hmm.
Remember that you have to go in, two elements are in the same row. So n on top must be same, right?
Same. Yeah.
And
Yeah.
then we have to add when you get, it becomes n plus 1 something, right?
Yeah. Yeah.
And the higher term here will become the r, whichever one is higher.
Yeah.
So it will be ncr minus 1, ncr becomes n plus 1 cr, right?
Yeah.
Then the next one is another Pascal's triangle identity. 1 1 1 2 1 1 3 3 1 1 4 6 4 1 1 5 10 5 10 10 5 1 1 6 15 20 15 6 1. Okay, we have written these, right? So
Yeah.
now this is called the hockey stick identity. Okay. The reason it is called hockey stick identity is this. Find the value of this plus this plus this plus this. Find the value of this plus this. Add all of them.
Mm.
What is it? Add.
Yeah. Yeah. So
What is the
all the way
addition?
down, right? Or only till 4?
Till 4.
Till 4. Yeah. Okay. So
It's 10,
10.
no?
Yeah.
Yeah.
So turn your stick. It's a hockey stick.
Oh, okay.
Okay. And anywhere it will work if you start from this side, right? So let's see this
So 1,
addition till
20.
here.
Mm.
It should be 20.
Yeah.
Okay.
Okay.
Anywhere.
Yeah. Yeah.
Yeah.
Mm.
Are you seeing this?
Yeah.
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 Right? So what will we write it as? So this term is 1C1, right?
Yeah.
1C0, 1C1, right?
Yeah. Yeah.
So 1C1, this term is what? 2C1, right?
Yeah.
This term is what? 3C1. This term is 4C1.
Force you. Yeah.
And that is becoming equal to 5C2,
Yeah.
correct?
Yeah. Yeah.
So if you keep your this term constant, right? The R constant, correct?
Mm.
And you
Yeah.
increase your this thing from 1 2 3 4, right?
Yeah.
It will become n plus 1 r plus 1, right?
Yeah. Yeah.
So the identity is ncr plus n n plus
Plus 1.
no, not like that. uh, it has to start from,
Start from
it can
1.
start from any place, right?
Hmm.
It can start from here also. So this was what 4. Okay, fine. uh, so you can write it as mcr, right?
It
So
has to start from one end, right?
yeah, it has to start from this end.
Yeah.
Yeah.
So
Yeah.
so you can write this identity in a general way as mcm, right? This is mcm, no?
Yeah.
And this term was m plus 1
And
c M, right?
M only, yeah.
M only, yeah.
M only, right? And that's M plus 2 cm, M plus 3 cm, right?
Yeah.
Yeah.
Correct. So that became M plus 4 c M plus 1.
Yeah.
That is not a nice way to frame it. Okay, let me just look at if there is it is written somewhere in your book and all. One second. I'm sure it will be written somewhere in the textbook. Uh, just hold on for a moment. Hockey stick identity general form. Okay. Uh, okay. So the general form is written as summation of r. K is going from r to n. Okay, and it is KCR is going to be n plus 1 CR plus 1. So let's just see whether it makes sense or not. So K is going from R. So you start off with RCR, right?
Yeah.
Then K
Yeah.
increases, right? R plus 1 CR, right?
Yeah.
R plus 2 CR, right?
Mm.
And you
Yeah.
go on till NCR, right?
Hmm.
And that becomes equal to n plus 1 CR plus 1. Now it makes sense, no?
Yeah.
You
Yeah.
can start from
Yeah.
any value of K, right?
Yeah.
1C1, then we went to 2C1, right?
Yeah.
C1, 4C1, then it becomes 5C2,
Yeah.
correct? And
Yeah.
you can start from this value also. This is 3, right? So this is 3C3 plus 4C3 plus 5C3 will become 6C4,
Yeah.
correct? Makes sense.
Yeah. Yeah.
Yeah.
Wherever you end, right? Then the answer of that series will be equal to n plus 1 CR plus 1, right?
Yeah. Yeah.
So this is an important identity. You will see many times that you have to add things like this, right? So keep in mind the previous fifth one, the Pascal's triangle basic identity, this plus this is this, right? That
Yeah.
was what?
Yeah.
NCR plus NCR minus 1 is equal to n plus 1 CR, right?
Yeah.
Yeah.
This
Yeah.
one. And the other one is the hockey stick
Hockey stick.
identity, which is from RCR you have to start and you have to increase the top coefficient, right?
Yeah.
Until
Yeah.
wherever you end
Till
up,
end.
and
Yeah.
keep the bottom coefficient constant, suppose, right? Until wherever you end up, the next answer is n, that top part plus 1 by bottom part plus 1.
Plus one. Yeah.
Yeah.
Okay. And you can verify it for yourself. It is going to be correct.
Yeah.
Yeah. So that is the identity. Then next thing is, let's try to find out the value of, for example, C1. Find the sum of the series C1 plus 2C2 plus 3C3 plus 4C4 plus so on till NCN. Okay. So far we had done things like C1 plus C2 plus C3 and so on, right? We had
Yeah.
gotten the sum of this series
Yeah.
plus Cn was equal to 2 power n, right?
Yeah.
But we have not gotten something like this yet, right? We have also
Yeah.
gotten this result, C0 square plus C1 square till Cn square is equal to 2n Cn, right?
Yeah. Yeah.
Yeah.
And we also derived as a problem this thing, correct? That you don't need to
Yeah.
remember, you need to remember how we got it, right? It was just 2
Hmm.
power 2n minus 2n cn divided by 2, right? Because you
Yeah.
use this and this to get this, right? But this is a different looking series, right?
Yeah. Yeah.
Yeah.
The way you approach it is first write your 1 plus x to the power n, and that is going to be c0 plus c1x plus c2x square plus c3x cube plus cn x power n, right? This is
Yeah.
your standard identity that we more or less all the time will be using, right? From here only you got this, no? Put x is equal to 1, right?
Hmm.
Yeah.
From this only we derived this, right?
Yeah.
Yeah.
Now we have to somehow use this to derive this, right? We'll try to use this.
Yeah.
Notice that the terms are such that the coefficients are coming here, right? 3, 2, right?
Yeah.
You
Yeah.
need somehow coefficients 2 here, 3 here, 4 here, n here, right?
Hmm.
Yeah.
So since it is an identity, I can perform mathematical operations on both sides of the identity and it will still remain an identity, right?
Yeah.
I
Yeah.
can do some stuff to it, both sides, right? So the
Hmm.
obvious thing to do is differentiate.
Yeah.
Differentiate with respect to x, because that will make this what? This part become c0 will disappear, right?
Yeah.
c1 plus
2
2c2x
plus
3c3x
3x
squared
square. Yeah.
and so on till n cn x power n minus 1, right?
Yeah.
And this side differentiation will become n into 1 plus x to the power n minus 1, right?
Yeah.
And now I will put 1, x is equal to 1.
Yeah. Yeah.
See, an identity, when you perform the same mathematical operation, it will still remain an identity. And
Yeah.
at the
Yeah.
end, you can put the value of x as 1, right?
Hmm.
So the answer will become simply n into 2 power n minus 1, right?
Yeah.
Correct?
Yeah.
Makes sense, no?
Yeah.
Yeah.
Yeah. Yeah.
So how are we using algebra and calculus together here? We are just basically thinking, I need this series, I start off with this identity, and to
Hmm.
get this coefficients, right? The only way is, the easiest way is to differentiate,
Yeah.
right? Correct.
Yeah. Yeah.
If someone asked you something like this, c1 plus c2 by 2 plus c3 by 3, right?
Yeah.
Correct. 1 second, let me just be sure about it. No, if someone asks you c0 plus c0 plus c1 by 2 plus c2 by 3 plus c3 by 4, right?
Hmm.
Plus cn by n plus 1, right?
Yeah.
Then again, I will think of 1 plus x to the power n as c0 plus c1x plus c2x square and so on, right?
Yeah. So
cn
now
x.
you
Now what
integrate.
should I do? Integrate it, right?
Yeah.
Because only by integration can I get x square by 2,
I
right?
do. Yeah.
So if I
Yeah.
integrate it, I will get an identity again, but I want to integrate in certain limits, right?
Hmm. Hmm.
I will get c0x plus c1 x square by 2 plus c2 x cube by 3 plus so on cn x power n plus 1 by n plus 1 plus constant, but I don't want these things to appear, right?
Yeah.
So I will not do a normal indefinite integration. I will do integration from 0 to 1.
Okay.
Okay. So,
Yeah.
so that
Yeah.
when you put the value of
One means.
1 or 0 here, when you put
Hmm.
1, it will become c0 plus c1 by 2 plus c2 by
Yeah.
3, which is the series that you wanted, right?
Yeah.
And plus c, and when you put 0, all of it disappears and minus c comes, right? Which cancel.
Yeah. Yeah.
Yeah.
So it is an integration from 0 to 1 of this. So that will become with respect to x. So that will become 1 plus x to the power n plus 1 by n plus 1 and 0 to 1. The answer is 2 power n plus 1 by n plus
N
1
plus one.
minus 1 power this, right?
Yeah. Yeah.
The answer of this series is 2 power n plus 1 minus 1 by n plus 1.
Yeah.
So basically what you have to learn is that this is your main thing, main weapon here. Sometimes it could be 1 minus x power n if you have alternating signs and all, right?
Mm-hmm.
And then after that you have to do some stuff to it. So
Yeah.
three things that we have done. So remember, one time I wrote it like this and then I reversed it, right?
Yeah.
And
Yeah.
that helped me get the square series, right?
Yeah.
Square terms. Yeah.
Right. So I'm just doing some manipulations on this. One time I differentiated it, right? You could also integrate
Hmm.
it, right?
Yeah. Yeah.
Suppose I do this. 1 plus x power n is there. C0 plus C1 x plus C2 x square plus Cn xn, right?
Mm.
Suppose I multiply both sides by x, right?
Yeah.
So every term becomes slightly higher power, right?
Yeah. Yeah.
And
Yeah.
then I differentiate it, suppose, right?
Mm.
So what is it coming? What is coming? Xc0 plus 2c1 x
Mm.
plus
Yeah.
3c2
3C.
x square plus so on till n plus 1 cn, right?
Yeah.
X power n, right?
Yeah.
And this
Yeah.
side is coming what? Differentiation of this is by UV rule, right?
Yeah.
First differentiate x, that is 1 into 1
1
plus x
into
power n plus x into n
n
into
into
1
1 plus
plus
x
x to the
power
power n
n
minus
minus
1,
1.
right? So this is
Hmm.
equal to this, right?
Yeah.
Now put 1, so you'll get the value of this series, right?
Mm. Mm.
Notice that if you had gotten this as a question, this could be a question that is given to you. Find the value of this, right?
Yeah.
Then
Yeah.
direct differentiation will not work, right?
Yeah. Yeah.
Because it is slightly shifted, no?
Mm. Yeah.
You understand? It is not, the direct differentiation would have given you C1 plus 2C2 and stuff.
Yeah. Yeah.
And it is C0 plus 2C1 and all. Slight shift is there, right?
Yeah.
So
Yeah.
multiplying by x first and then differentiating. So this, when you put 1, it will become 2 power n plus n
n.
into 2 power n minus 1.
Yeah.
So that is basically n plus 2, 2 power n minus 1, right?
Yeah.
Hmm.
Correct. So
Yeah.
such questions can be there. If I had put minus 1 here, right?
Mm-hmm.
Minus 1 here, I would have said that C0 minus 2C1 plus 3C2 minus minus whatever,
Minus.
right,
Yeah.
is equal to 0 minus 1 into n and 0, 0.
Yeah. Yeah.
You understand?
Mm.
Yeah.
So questions could be a little complicated here. It's about thinking, what should I do? What operation can I do to somehow get the series that I want, right?
Mm.
It's a
Yeah.
little bit of a, like, you have to solve many cases to be comfortable with it. Like, unless you do
Mm-hmm.
many cases, you will not feel confident here because there's no one pattern that you can follow,
Yeah.
right?
Yeah.
It's like checking what will work, right?
Mm.
So this is one thing. Then is there something more that is important here? Let me think 1 second. uh, okay, I thought I had something that I wanted to discuss. 1 second. Hmm. Differentiation, integration we have seen. Yeah. Yeah, I'm unable to remember right now. I thought I had one more point that I wanted to mention, but uh, we'll continue from here in the next class. I cannot recall it right now. So what you should do right now, I will send you the sheets, okay?
Yeah.
And start reading the theory, start reading the theory a little bit, and do exercise 1, 2 types, right?
Yeah. Yeah.
Start trying it and see the series type of questions. For sure, the series type of questions are the type of questions that generally people find difficult, okay? So there you have to use some imagination, okay?
Yeah. Yeah.
Try the series type of questions definitely, and a little bit is left, just a little bit of theory, some more examples of series summations,
Yeah.
examples of series summations, and something called multinomial theorem. Multinomial theorem is there. Uh, multinomial theorem is basically what happens if I have three terms, right?
Yeah. Okay.
It's not a binomial, it's a multinomial. Okay.
Yeah.
Yeah.
What happens if you have three terms and you have to do a fourth power, right? Then how will you start writing it, right?
Yeah.
So actually, the long way to do it is basically simply take it as a binomial, right?
Yeah. And then again
Take it as a binomial, make two terms, then you will get, you have to do it twice, right?
twice. Yeah.
You will have to do NCR x plus y to the power n minus r z power r, but then you'll have to do this also, right?
Yeah.
This is also a binomial inside, right?
Yeah.
Correct. So this binomial can be expanded as n minus r c 0 and c say s, right? And s goes from 0 to n minus r x power n minus r minus s and y power s, right?
Yeah. Yeah.
Yeah.
And outside there is an ncr, right? And
Yeah.
z power r, right? Correct.
Yeah.
So there will be
Yeah.
many terms here. However, we will understand how to write the series. The formula is quite simple here. So already, if you know binomial theorem, you can derive any expansion, because all the time you can keep taking it two at a time,
Yeah.
and keep
Yeah.
repeating the process, right? But that is not the best method. We'll learn what is to be done in that case. So a little more theory is there, probably one more class worth of theory, and try the problems now. Okay,
Yeah.
so try the problems, do a few examples, come prepared for the next week's class. Okay,
Yeah.
I'll
Yeah.
send the sheets right now. On Thursday, we will continue with our chemistry. Chemistry, we had almost finished that rate equation, no? Rate kinetics, right?
Yeah.
So
So
just try a few questions and come, okay? Kinetic.
yeah. Yeah.
Make sure that you have applied it on a few 20-30 problems at least and seen that you understand the equation.
Yeah. Yeah.
You understand the equation, you understand how to apply it and stuff, right? Because I want to start equilibrium. So unless, I hope you have that, you have understood kinetics and you can predict what is going to happen in different situations and stuff, right? So do the McMurray a little bit of the exercise at all before the chemistry class, right?
Yeah.
Okay, fine. That's it for now then. Okay, bye.
Bye, sir.
That's all.